This is Professor Michael Fournet again, and this is the second lecture for week 4, where we're looking at how to build a model for the economy. And this model building process began for us in chapter 27, where we introduced the consumption function, savings function, and the concept of the multiplier to help us to start laying the foundation in the model building process. And so in chapter 28 we want to build the entire what is known as the aggregate expenditure model, and this model will help us to see how expenditures in the economy, how they are related to income, and also to be able to identify ultimately what are called economic gaps. That is, when there's a mismatch between expenditures in the economy and income with respect to full employment. All right, so this chapter really is an extension of chapter 27, and once we're done with this chapter, next week, week 5, we will apply policy to the aggregate expenditure model to try and eliminate the economic gaps that we're going to introduce in this chapter. So it's a nice sequence. Chapter 27 can be kind of like a foundational chapter for building the model. Chapter 28 we will actually build the model, and then in chapter 30, which we will discuss next week, we will use fiscal policy to address any type of economic gaps that exist in the economy. Alright, so the aggregate expenditure model is just a collection of all expenditures, because to aggregate means to combine. So we combine all the expenditures in the economy and look at their behavior with respect to income. Alright, and so when you're looking at the aggregate expenditure model, so AEM will stand for aggregate expenditure model, you can identify different types of economies. For example, if aggregate expenditures just consist of consumption expenditures, that type of economy is called a closed private economy. It's closed because there is no exporting or importing, so the economy is closed off from the rest of the world. And it's called private because consumption is the biggest part of the private sector. So if aggregate expenditures just consist of consumption, that type of economy is called a closed private economy. If you add gross investment to the definition of aggregate expenditure, where you have C plus I sub G, the economy is still closed because there is no international trading, and households consumption and investment expenditures business sector, those two sectors make up the private sector. So C plus I sub G is the more precise definition of a closed private economy. When you add government to the definition of aggregate expenditure, when you add government expenditures, then the economy becomes what we call a closed mixed economy. Closed because we have C plus IG, which is the private sector. G is sometimes known as the public sector, so you have a mixture of the private sector and the public sector, and so the economy is said to be mixed. Still closed because there is no exporting and importing. Now, if you take the model to completion and you look at aggregate expenditures consisting of consumption, gross investment, government spending, and net exports, the economy under those conditions is called an open mixed economy. Open because now we're trading with other countries through the net export component, and mixed because we have C plus IG, which is the private sector, G, the public sector, and X sub N, the international sector. So the open mixed economy is really representative of the U.S. economy because we have a large household sector, business sector, government sector, and we do engage in trade. So the U.S. economy is actually an open mixed economy. So our quest in this chapter is to rapidly build a model up to the open mixed economy level so that we can see how all expenditures, when they are changing, how it affects economic performance. Now, some basic features of this model so that it's less intimidating. It's a very clever model. what you're really doing is you're stacking expenditures on top of expenditures. So if you start with consumption expenditures, that's going to be the biggest block of expenditures, because consumption represents about 70% of all expenditures in the economy. And then on top of that, we can add investment expenditures, we'll add government expenditures, and we'll add net exports. And so as you have more expenditures, you're going to have also more income, or GDP, in the economy. So as GDP gets larger, C plus IG plus G plus net exports, you will have also more income. So that's the basic premise of the model. More expenditures, more income; less expenditures, less income. Alright, now in this model, from the Keynesian perspective, investment plays a very interesting role. So investment helps to explain a lot of the movements that we're going to see in the aggregate expenditure model. So it requires us to take a moment to take a closer look at investment. And so investment actually can be broken into several components. There's the actual investment, which I'm going to use a symbol I sub A to represent. And just as the name implies, it's the actual amount that businesses expend on both capital goods and inventories during some time period. So it's how much they spend on inventories, is how much they spend on capital equipment. That represents actual investments, how much they actually spend. Now in this model, to know actual investment is to know savings. That is, because actual investment is how much businesses are going to spend on capital goods and inventories. And it begs the question, where are they going to get the funding to incur those expenditures? And as we saw in chapter 27, when households don't spend all of their income, the extra income goes into savings. So as the household savings pool builds up, that represents a nice funding source for business expenditures. So in the model, by saying actual investment equals savings, we're really saying that household savings serves as the funding source when businesses buy capital goods and inventories. Another investment concept in this model is called planned investment, and I'll use the symbol I sub P to represent that. Planned investment is kind of like a target amount of investment. Is how much we want businesses to spend. You know, our quest is, from a policy standpoint, is to push the economy to full employment. And we need the various sectors of the economy to, if you will, pull their own weight. The household sector is going to do most of the spending, but we also need businesses to spend a certain amount as well. And the amount we need them to spend is called planned investment. So it's how much we need businesses to spend to keep the economy moving towards full employment. Now, any mismatch between actual investment and planned investment will be reflected in terms of changes in inventories. So there's another component of investment called unplanned changes in inventories, and it's simply tracking what happens to inventories in the economy when how much business spend differs from how much we want them to spend. That is, when actual investment differs from planned investment. And we're going to let that difference give us insight about what happens to inventories throughout the economy. To give a little more insight concerning that, we have the relationship actual investment is equal to planned investment plus unplanned effects on inventories, I sub U. Now, if actual equals planned, that is, if what businesses spend equals how much we want them to spend, then the effect on inventories will be zero. They'll be normal. So when actual equals planned investment, unplanned effect on inventories will be zero, or normal. This is going to be reflective of what is known as macroeconomic equilibrium. It's where aggregate expenditure will equal GDP. So when businesses spend an amount equal to the amount we target or desire, inventories will be normal and the economy will be in an equilibrium condition. Now, if how much businesses spend exceeds how much we want them to spend, so if actual is greater than planned investment, that's going to cause inventories to be excessive. Inventories will start to build up, because businesses have kind of overdone it. They spent more than we wish. And so when inventories build up, it's going to be indicative of GDP being greater than aggregate expenditures. And it's going to suggest recessionary conditions in the aggregate expenditure model. That is, with excessive inventories, that's a clear sign of recessionary conditions, because when inventories are building up, sales are sluggish, and sales tend to be very sluggish during periods of recession. So we'll use I sub U when it's positive as an indicator that the economy is experiencing recessionary conditions because inventories are building up. Now, when the amount businesses spend is less than we want them to spend, when actual investment is less than planned investment, that's going to cause inventories to drop, to drain. So I sub U will be below normal. So planned effect on inventories will decrease. Inventories start to shrink, and that's going to be a sign that aggregate expenditure will be greater than GDP. And when that is true, that's a sign that the economy is growing too fast because inventories are shrinking, and it's going to be a sign that there are going to be some inflationary conditions or inflationary concerns in the economy. So we'll use the relationship I sub A equals I sub P plus I sub U as a way of tracking how inventories are changing. And how inventories change will tell us about the current state of the economy. Now, another dynamic set of things that will take place in the model will be the interactions between what are called injections and leakages. You can kind of think of injections as things that when they increase, there are things that cause GDP to increase. For example, if we have more consumption, GDP gets bigger. If we have more investment, GDP gets bigger. If we have more government spending, GDP gets bigger. If we have more exports, GDP gets bigger, because when the goods are sent to other countries, income flows back to the United States, which bolsters the level of GDP. So consumption, investment, government spending, and exports are considered injections, because when they get bigger, their effect is to make income and hence GDP larger. Now, there are also these things called leakages, and I refer to them as initial leakages, because their initial impact is to cause income and GDP to fall. But there is some subsequent activity that cannot be captured in the model that we're going to work with, and so I'm just going to refer to these as initial leakages, and I'll explain why. Savings, for example, is looked at as an initial leakage. That is, if savings go up, consumption has to drop, as we saw in chapter 27. Consumption drops, income falls. Now, why do I call it an initial leakage? Well, when savings go up, as we're going to see, savings will feed into investment. So savings will fund investment expenditures. Remember, actual investment equals savings. So we're looking at the initial effect of savings. When it goes up, consumption goes down, income and GDP falls. Taxes also we look at as an initial leakage, because when taxes go up, that makes things like consumption fall, and when consumption falls, income falls. So, for example, an increase in taxes would cause income clearly to fall. You have to pay more taxes, your income shrinks. Now, the taxes, when they go up, however, they are supporting government expenditures. So taxes is a way that the government collects money for spending. So I'm going to look initially at taxes just going up, causing income to go down. I'm going to ignore the fact that when taxes go up, they actually fuel government spending. Imports are easier to see as in terms of their role as leakages. Imports go up. The goods are coming into the United States because we're importing more. Now we have to compensate the countries from which those goods came, so income leaks out of our economy and it goes to other countries. And so imports is also an initial leakage as well. Alright, so the injections are things that make income and GDP go up. They are the basic expenditure categories. Leakages are things that when they initially increase, they make income go down, or GDP go down. Alright, so to play with the aggregate expenditure model, I'm going to do it two ways. We're going to use numbers first to look at the relationships between aggregate expenditures and GDP, and then we're going to use those numbers to convert the results to a graphical version of the aggregate expenditure model. So that's my approach, is to build it numerically first, and then from the numerical results look at it graphically. Alright, so in order to do that, let's say we have the following example. So here's an example of an aggregate expenditure model, and it's in tabular form, just using numbers. I have a column here that's tracking GDP, so this is GDP as it's changing over time. I have a column that tracks consumption, and note that consumption changes consistently in increments of 15 billion. We'll say these numbers in terms of billions. I can track savings because consumption plus savings equals the income, DI. We have investment, and investment here is fixed at 20 billion. So we need businesses to spend consistently 20 billion. So this type of investment is really the planned investment. It's how much we need businesses to spend to keep the economy moving towards full employment. Net exports, you notice I have net exports as 0. So what I'm assuming is that the exports that are occurring are being offset perfectly by the imports. So we have like balanced trade. And this is just to avoid a lot of excessive clutter in the model. And so we're going to assume that on the net export side we have balanced trade where exports equal imports. And then we have a government sector, and we're going to let government spend also $20 billion and have it make that contribution to the economy. So to get the aggregate expenditure number, you simply take the consumption, the investment, the net exports, and the government spending, and you sum them up, as I've demonstrated here in the aggregate expenditure column. And if you notice, the aggregate expenditure, when it's 550 billion, happens to be the same as GDP at 550. So when aggregate expenditure equals GDP, you're at the economy is said to be at equilibrium, right? And so when that is true, when the economy is in equilibrium, inventories should be normal. I sub u should equal 0. And so to kind of get a sense of that, we see here that planned investment is 20 billion. Household savings, which is the funding source for for business expenditures, is 40 billion. We have a government, however, that's spending 20 billion. So government, if you take the injections, you take the government expenditure of 20 billion, the investment of 20 billion, that's 40 billion. And so that equals the leakage, which in this case is savings, which is 40 billion. And when leakages equal injections, you're at an equilibrium condition. So in this case, we can assume that when actual investment is 40 billion and planned investment is 20, unplanned effect on inventories will be 20 billion. But the extra inventories are being purchased by government. So government's purchasing the unplanned effect on inventories. And so we're at an equilibrium condition. Now, if I keep extending the model, keep extending these patterns, I see that at what I call full employment GDP, I see that aggregate expenditure is 595 billion and GDP at full employment is 610. So if we extend the model to our definition of full employment, we see that aggregate expenditures are less than GDP. And what we desire is for aggregate expenditures to equal GDP. We want the economy to be in equilibrium at full employment. Right now, the economy is in equilibrium at an income level that's less than full employment. Right? Now, so from these numbers, we can observe the following. From the numbers, because every time consumption changes, it changes increments of 15, and the income changes in increments of 20. So it means that the MPC for this economy is 0.75. if the MPC is 0.75, the MPS has to be 0.25. Because we learned in the previous chapter, the MPC plus the MPS always equal 1. So if the MPS is 0.25, then the multiplier, which we also introduced in the previous chapter, would be 4. You would take 1 over 0.25, or 1 over 1/4, and you get a multiplier value of 4. That's going to be useful as we try to explain what happens in the model subsequently. So right now, the economy is in equilibrium, and it's in equilibrium somewhere less than full employment. And so if I take this information and I look at it graphically, we have the following result. So here is consumption expenditures. I stacked on top of that investment expenditures. Net exports is balance. And then on top of C plus I plus net exports, I now have added government. So I'm literally stacking expenditures on top of expenditures. And the biggest block, of course, is consumption, because it represents the largest expenditure category. Now, as we saw from the table, the economy was in equilibrium at 550 billion, as we saw earlier. Let's go back to take a look. The economy is in equilibrium at 550 billion, and at that point, at the equilibrium point, aggregate expenditure, which is the current definition of aggregate expenditure, is this black line. It coincides this 45-degree line, which is tracking really real GDP on the horizontal axis. So at this intersecting point, the economy is in equilibrium, and the income that's being realized is 550 billion. Now, so if we go over to how we define full employment, where the income was 610 billion, we can go back to the previous table to check that out. So our definition of full employment was where the income was 610 billion. So the income, or DI, was 610 billion. And so what that implies then, at this level of income, 610 billion, aggregate expenditure is 595, and the real GDP, which is being tracked on the horizontal axis, is 610. So the aggregate expenditures at full employment are less than the real GDP, the income. And so this is not desirable, because what we want is the economy to be in equilibrium at full employment. So we need the expenditures at full employment to match the income. And so to do that, we need to do something to make the aggregate expenditure function thicker, to make it shift up. If we can make it thicker, it shifts up, and ideally we want it to cross the real GDP line, this 45-degree line, have them equal at full employment. Then we would have the economy at equilibrium at full employment. And so notice, the aggregate expenditure at full employment is 595, the income is 610. So the expenditures need to be increased by the difference, which in this case would be 15 billion. And so if we can increase expenditures by 15 billion, that would make the aggregate expenditure line shift up to where it was equal to the income at full employment. So our equilibrium would change from here, 550, to where we'd have equilibrium at 610. Now the question is, how much do we need to increase the expenditures to make it the same as the income? Well, you increase the expenditures by the difference. If the expenditures currently are 595 and the income is 610, if we can make the expenditures 610, that would equal the income at full employment, and we have equilibrium at full employment, which is our goal for the economy. Now, so to try and accomplish that, what I've done is I went back to our tabular model, and now I've increased the level of government spending by 15 billion. Because if you recall, in the first table, the level of government spending was set at 20 billion, and so now I've increased it everywhere to 35 billion. So government spending now is $15 billion larger. And so by increasing government spending, when we go back to full employment, we see that here the aggregate expenditure now is 610 and the income is 610. So our equilibrium would move from that old position to this new position of aggregate expenditure equaling income both being 610. Now, what this suggests is the following: is that if I look at this graphically by simply increasing government spending. Initially, we had government spending where it was 20 billion, and we have this difference between aggregate expenditure and real GDP at full employment. I increased government spending. I'm calling it now G prime, where G prime is now set at 35 billion as opposed to 20 billion. That makes the aggregate expenditure line thicker to where it coincides with real GDP at full employment. So our equilibrium has moved from initially in table 1, 550, to now in table 2, it's at 610. So literally, when you're playing with the aggregate expenditure model, you're adjusting the level of expenditures so as to have the expenditures coincide with income at full employment. It's literally stacking expenditures on top of expenditures, or sometimes reducing the level of expenditure. It's really a stacking process, making the blocks bigger or making the blocks smaller as need be. So we increased government expenditures by 15 billion. But notice, real GDP increased by 60. From in the original equilibrium, it was 550. Now in the new equilibrium, it's 610. So the income, the real GDP, increased by 60 billion in response to an increase in expenditures of only 15. And the way we explain that is due to our good friend, the multiplier. So to explain this change in GDP, we take our multiplier, which is 4 in this case, and we multiply it times the component of aggregate expenditures which changed. And I changed government spending. I changed it by 15. So I take the multiplier of 4, multiply it times the increase in government spending, in this case of 15 billion. That gives me the change in GDP of 60. So it's not mysterious that the income grows by 60 billion, because when we increased government spending by 15 billion, that activated the multiplier process, and the multiplier process made income increase in a multiple fashion from 550 billion to 610 billion, which is an increase of 60 billion. So we can explain this thanks to the multiplier. That $15 billion additional injection by the government caused income in the economy to grow openly by 60 billion. Okay? Alright, so having said that, we look now at the numerical version of the aggregate expenditure model, and we looked at some graphical results to kind of corroborate the activity in the model. The next thing we need to look at are what are called gaps, economic gaps. And there are two types of gaps that are undesirable. One is called a recessionary expenditure gap, and the other is called an inflationary expenditure gap. And any discussion of gaps has to be linked to full employment. So these economic gaps are concepts we observe when we compare aggregate expenditure to real GDP at full employment. And so in the case of a recessionary expenditure gap, with respect to full employment GDP, unplanned changes in inventories will be positive. So when you study a recessionary gap, you're going to find that I sub P is going to be greater than 0. And it makes sense, because if the economy is in recession, sales are sluggish, and inventories should be above normal. Inventories should be building up. So I sub P should be greater than 0. You also will find, when you have a recessionary gap, that when you compare where the economy is currently in equilibrium, it's going to be less than full employment GDP. So the economy literally will be stuck somewhere less than its potential, which is full employment. And that makes sense as well, because a recession is a condition where the economy is not performing well, and it's definitely not performing up to its potential or full employment. Now, in looking at the recessionary expenditure gap, Keynes came up with some proposals, and his proposal was when the economy is not at full employment, one way to do that is to have government spend more, like I demonstrated in the graphical depiction of the gap. When government spends more, that makes aggregate expenditures increase. Aggregate expenditures increase, it then makes aggregate expenditure coincide with real GDP at full employment. So Keynes' solution would be to have government spend more or reduce taxes. And if you reduce taxes, taxes, as we will see, are designed to indirectly influence consumption. So if you reduce taxes, income goes up, consumption goes up, and the trick will be to have consumption increase enough to make aggregate expenditure increase enough to close any disparity between aggregate expenditure and real GDP at full employment. So recessionary gap is one phenomenon that we want to look at, and we're gonna use policy, what's called fiscal policy, in chapter 30, the next week's lecture, to show how fiscal policy can be used precisely to get rid of a recessionary gap. An inflationary gap is just the opposite of a recessionary gap. Again, you're looking at the gap from a full employment perspective, and here unplanned changes in inventories will be negative because the economy is growing too fast. We have an inflationary expenditure gap. The economy is growing too fast, and that's going to drain inventories. So ISO P will be less than 0 in this case. And so as a result, the inventories will be below normal. Where I'm saying I sub P, this really should be I sub U. This really should be I sub U. I'm sorry for that. Unfortunately, a typo creeped into my presentation. So I sub U would be greater than 0. I sub U should be less than 0. So sorry. Now, so inventories here would be below normal. And we also find, very strangely, that where the economy is in equilibrium will be perceived as greater than full employment. Is what we call the inflation illusion. It's giving the impression that the economy can do more than it's capable. Now, the Keynesian solution to an inflationary expenditure gap would be to decrease government spending. By decreasing government spending, aggregate expenditures drop. Aggregate expenditures drop to where they coincide with full employment at real GDP. Or the other option would be to raise taxes. If you raise taxes, income drops, consumption drops. And you want consumption to drop enough so that aggregate expenditure will drop enough to where aggregate expenditure will coincide with real GDP at full employment. So we'll look at in chapter 30 exactly how much to change government spending, exactly how much to change taxes so as to get rid of the recessionary expenditure gap and the inflationary expenditure gap. Again, please note that where I'm stating here I sub P, this really should be I sub U. How about that? And this really should be I sub U. And so now the graph is correct, the presentation is correct, and I can sleep tonight. Alright, so this will be, these are the culprits that we're trying to identify in the economy. Recessionary gap, inflationary gap, these are their features, and the Keynesian solutions will be implemented through fiscal policy in chapter 30. Alright, so until next week, please take a look at both chapter 27, where we laid the foundation for the model that we've just studied here in chapter 28, and please play with the model as indicated in the homework. You'll see that it's really quite fascinating once you get a hang of it, and once you get a hang of it, it'll reveal some very useful information about the economy. Alright, so until next week when we talk about fiscal policy, take care.